In this video, we're going to continue doing unit conversion practice. Then we're going to proceed to look at temperature conversions. And lastly, we're going to understand the concept of density. In the following practice problem, the problem reads, if an intravenous solution is infused at a rate of 0.425 milliliters per minute, how many hours will it take to administer 173 milliliters of solution? As we've done previously, let's write down the information given in the problem. Overall, here we have two pieces of information. The first piece of information that we have is the rate of the infusion, which states that 0.425 milliliters of the solution is going to equal 1 minute. The other piece of information is going to be the volume of the solution that needs to be administered, which is 173 milliliters. Overall, looking closely at the question that this problem is stating is that we need to find hours for specifically the 173 milliliters of solution that need to be administered. So let me put a question mark before the word hours. So with these two pieces of information, how do we get to the answer? In a problem like this, the first thing that we need to write down in order to set up our dimensional analysis is the volume that we have for the solution that needs to be administered. And in this case, it's going to be 173 milliliters. Next, we are going to utilize the rate that is given in the question as a conversion factor. Since the units of 0.425 milliliters match the unit for the volume, that's going to be placed in the bottom of the fraction. So we're going to write 0.425 milliliters in the bottom. And then on the top, we're going to write what it equals to, meaning 1 minute. This is going to cancel the units of milliliters. And if we take 173 and divide it by 4.25, the only thing that we have accomplished is how many minutes it will take. Since the question is asking for hours, the next thing that we have to do is actually find a conversion factor that will take the unit of minutes and convert it to hours. As you can see here, we have two conversion factors for time. And the one that we need to utilize to convert from minutes to hours is the first one. So we can write down another fraction and convert the minutes to hours by writing in the bottom 60 minutes and on top 1 hour as the equality that is going to help us convert from the unit of minutes, which is now going to be canceled, to the units of hours. The way that we enter these values onto the calculator is by taking 173, multiplying it by the value of 1, multiplying it by the value of 1, and then taking that result and dividing it by the result of taking 0.425 multiplied by 60. Notice that I put it in parentheses, and that's how it must be entered in the calculator. So when we enter this in the calculator, 173 divided by 0.425, I'm skipping the times 1 because that equals 173. Then I take 173 and divide it by the result of 0.425 times 60. I see that my calculator display shows me a value of 6.7843, and there's a series of numbers after that. Since my measurement given is 3 significant figures, then that means that I'm going to take my calculator display and specifically illustrate 3 significant figures. So my final answer is 6.78 hours. In this practice problem, let's read the statement. It says, a physician orders 0.12 grams of garamycin to be administered intravenously every 12 hours. The vial on hand is labeled 80.0 milligrams per 2.00 milliliters. The basic question is, how many milliliters should be administered per dose? So when it comes to this, and similar to what we've done before, let's write the information that we have specifically for the problem. First, we have the doctor's orders, which state that we need to give the patient 0.12 grams of the medication, garamycin, specifically every 12 hours. Next, we have a specific amount of garamycin that can be delivered for a specific volume. So the information in that second sentences, meaning the vial on hand, that's what we called the clinical factor. Let me highlight it. So this is the medication on hand. That's what we know as the clinical factor. In this problem, my clinical factor means that for 80.0 milligrams of the medication, in order to obtain that, that is going to equal 2.00 milliliters in volume. And overall, I need to know how much medication in milliliters I need to give the patient. So the question in this problem is going to be milliliters per dose. Notice that there's has nothing to do with the 12 hours. The 12 hours is just saying how often it needs to be there. The only time that we will use this information in a problem is if the question asks us, for example, how much, how many milliliters we need to give the patient in a day, for example. But since that is not in the question, the 12 hours, they don't need to be used as part of the final answer. So taking this into consideration, every time we're doing this type of problem, particularly this is known as a dosage question or a dosage problem, meaning that we are going to be calculating how much medication we need to administer. When we have these type of questions, the first thing that you need to investigate is specifically the unit of measurement that I have in my clinical factor match the doctor's orders. The reason why we need to investigate that is that if they don't match, then we have to adjust and do a calculation in order for them to match. As we can observe, the unit for the doctor's orders is grams, while the unit of the clinical factor is milligrams. So before we even set up the problem in terms of dimensional analysis, the first thing that we need to do is that we need to make the doctor's orders be changed into the unit that it is present in the clinical factor. So we must change from grams to milligrams. So practicing from the metric to metric conversions that we learned to do in earlier videos, we know that 0.12 grams, if we're trying to convert that into milligrams, we need a conversion factor. When it comes to this conversion factor, let's understand that as we look through the tables that have been illustrated in previous slides, 1 gram is going to equal to 1,000 milligrams. And when we set up the dimensional analysis, 0.12 grams for its conversion to milligrams means that we're going to put the unit of 1 gram in the bottom. On the top, we're going to put 1,000 milligrams. And when we put this in the calculator, 0.12 times 1,000, that means that our result is 120. So that means that 0.12 grams equals 120 milligrams. Now that we have a match in terms of our clinical factor in our doctor's orders, then we can start setting up to solve for the milliliters that need to be administered. So the first thing that we write down is going to be the doctor's orders, 120 milligrams. Then we are going to utilize specifically our clinical factor as a conversion factor. And since this 120 is for the medication, and we need to match the units, that means that out of this equality, this number is what goes in the bottom of the fraction. So we write right here, 80.0 milligrams of medication. Then you can observe that at this point, the milligrams of medication cancel with the milligrams of medication. On the top of the fraction, we're going to write what those 80.0 milligrams of medication equal to, which is 2.00 milliliters. When we enter this in the calculator, we need to write it as 120 times 2.00, close the parentheses. The result of that, we are going to divide it by 80.0. When we do that, we do 120 times 2 divided by 80.0. So my final answer is going to be 3.00 milliliters. When it comes to this question, technically, because the doctor's orders are with 2 significant figures, then we can eliminate that second 0 that I placed there. Understand that when it comes to dosage questions, typically in exams, I tend to remind students either give me a whole number or give me a specific number of significant figures. In the rest of the conversions, I am assuming that you will be able to determine the number of significant figures in the number given, and that's going to translate to the number of significant figures in the results. So only for dosage questions, I tell you how many significant figures you should report. When it comes to temperature scales, which temperature specifically is going to be the physical property that tells you how hot and or how cold something is. We're going to use equations that are going to allow us to convert from one unit to the next. When it comes to temperature, the basic unit of measurements for temperatures are Fahrenheit, Celsius, and Kelvin. So that's why we can see that when it comes to temperature scales, we can interconvert between the Celsius scale, the Kelvin scale, and the Fahrenheit scale. The equations for doing these conversions, you can see them here. And there's four equations that you need to be familiar with. And when it comes to exams, they are not provided. Let's do a practice problem for temperature conversions. The following problem reads, a parent is worried because their child has a temperature of 100.8 degrees Fahrenheit. What is this reading in degrees Celsius and Kelvin? You can observe that overall, the given number here is 100.8 degrees Fahrenheit, and it needs to be changed to degrees Celsius. Let me just move the information. Let me redo it. And we need that same temperature of 100.8 degrees Fahrenheit, and we need to convert it to Kelvin. So when it comes to this conversion, you can see that I already wrote in the problem the equations that I need. When it comes to temperature conversions, remember that we have a specific equations. The final answer needs to have the same number of significant figures as the measurement given. So you can see that the following measurement has specifically 4 sig figs. So your answer needs to have 4 sig figs overall. So for the first conversion, going from Fahrenheit to Celsius, what we are going to utilize is specifically this equation. So we're going to say temperature in Celsius is going to equal 5/9 times 100.8 minus 32. When we enter this in the calculator, the first thing that we need to do is the subtraction. So you take 100.8 and you subtract it from 32. Then the resulting value, which is 68.8, you're going to multiply it by 5, and then you're going to divide it by 9. That means that the calculator display is going to show you a value of 38.2222 many times after that. We need to round it to 4 significant figures. So the final answer for this conversion is going to be 38.22 degrees Celsius. When it comes to the conversion between Fahrenheit and Kelvin, there is no direct equation for Fahrenheit to Kelvin. But since specifically we have an equation that will convert from Celsius directly to Kelvin, we can utilize the information obtained in the first part of this problem and then utilize it to solve from Fahrenheit to Kelvin. So at this time, we're going to use this equation to solve the problem. And at this point, we will say 38.22. If we add it to 273, That's going to give us the degrees in, not the degrees, it's going to give you the temperature in Kelvin. Our calculator display illustrates 3.11.222222. So when we round that value to four significant figures, the result for this problem is 311.2. Lastly, when it comes to this chapter, the last thing that we look at is in terms of density and its applications. Density is a physical property, and it is the number obtained by dividing the mass of a sample of matter by its volume. So that means that when it comes to density, density has an equation, and we can see the equation from density here. Density equals mass over volume. At times, you can see the abbreviation for each one of those measurements. So that's why D equals M over V can also be utilized. The density of solid substances is given in units of grams per centimeters cubed, while the density of liquids tend to be given in grams per milliliter. We can observe specifically on the right side of the slide many images of different glasswares that can be utilized in order to determine the volume specifically of liquids. Let's now do some practice problems for calculation of density or the other different properties or quantities that can be derived from the density equation. Let's read the first practice problems. Low density lipoprotein cholesterol, meaning LDL cholesterol, is often referred to as bad cholesterol, and we can see an image of that in figure 1.31. If a blood test reveals that a 0.35 gram sample of LDL has a volume of 0.353 milliliters, what is the density of the LDL sample in grams per milliliters? So in part A, in this practice problem, what we're doing is calculating density. We can observe that the information given in this problem is going to be the mass of the LDL, which is 0.365 grams. And we also have the volume of it, which is 0.353 milliliters. The question asks for density, and since density is mass over volume, what we're going to do is take 0.365 grams and divide it by 0.353 milliliters, and that's going to give us units of grams per milliliters. The value in the top has 3 sig figs. The value in the bottom has 3 sig figs. So when we look at this problem and we enter in the calculator 0.365 divided by 0.353, we have a calculator displayed that is 1.0339, and there's a series of digits after that. Because this measurement has 3 sig figs and this measurement has 3 sig figs, we need to round the value obtained in the calculator display to 3 sig figs. So our final answer is 1.03 grams per milliliter. Let's look at problem B. It reads, the density of iron metal has been determined to be 7.20 grams per centimeters cubed. Use the density value to calculate mass in kilograms of an iron sample that has a volume of 35.0 centimeters cubed. Let's write down the information given. Here we have density for our object, which is iron. And that density is 7.20 grams per centimeters cubed. We also have the volume for our object, which is 35.0 centimeters cubed. And then the question is that we need to know mass in kilograms. So this is where we're going to utilize some algebra in order to use the density equation and separate only the mass term in it. So if we know that density equals mass over volume, we can separate the mass term by multiplying both sides by volume. What that means is that if I rearrange the density equation to isolate the mass term by itself, that means that mass is going to equal density times the volume. You can do a similar isolation for calculating volume. And even though it's not needed in the question, I'm just going to write it in the corner, which states that specifically, if you're trying to calculate volume, I'm just going to write it here as a note. If you're trying to calculate volume by itself, this means that overall, what we have is that mass over density is going to be able to give you the volume term by itself. But continuing on with problem B, now that I know the equation for solving for just mass, I'm going to utilize the information given. Mass is going to equal the amount in terms of density, 7.20 grams per centimeters cubed. And I'm going to multiply it by the volume, which is 35.0 centimeters cubed. When I do this multiplication, the term centimeter cubed cancel, and the mass that I obtain is going to be in grams. So let me use my calculator and take 7.20 and multiply it by 35.0. Overall, I get a value of 252 grams. This measurement has 3 sig figs. This one has 3 sig figs, and my calculator display illustrates 3 sig figs. So that is set. But I need to do the last step that is required by the question. Right now, I have my mass expressed as grams. I must change it to kilograms. And if I'm trying to do that, what I have to do is say, well, I know that based on the tables provided, 1 kilogram equals 1,000 grams. So if I take the value 252 grams and I divide it by 1,000 grams, and on the top I put 1 kilogram because I'm trying to cancel the units of grams, that means that I'll be able to convert from grams to kilograms. So the final answer for this problem is going to be 0.252 kilograms, which is the right unit specifically for what the question asked.